Hi, I wanted to show you guys how to do a calculation using the equation. We call this equation MCat because kind of looks like MCat, but really that's a delta for a change in temperature. This is a way to calculate energy when temperature is changing. And when we use this equation, we do need to use specific heat. Specific heat is something that every substance has its own constant specific heat. And if you forget what specific heat is, look at the unit. It says it's joules per gram degree Celsius. So for water, liquid water, it's 4.18 joules to take 1 gram of water and raise it 1 degree Celsius. So water is going to be, more likely to change temperature easily than something that would have a higher specific heat. For this question, we're dealing with benzene, and it is liquid benzene. So this is the value that we're going to use. So we are, Q is our energy. Mass has to be in grams, specific heat. And then our change in temp is always going to be the final temperature minus the initial. So sometimes you do get negative values, and then you get a negative Q, which means that the energy is being released from the system into the surroundings. So for this question, if I sub in my 10.5 grams, my specific heat of liquid benzene, did I pick the wrong one? My specific heat of liquid benzene. So my specific heat of benzene is 1.74. So I would sub that in. And you don't have to, but I like to put the label because then everything can cancel out. And then our change in temp, final temp is 80 minus initial. You wouldn't have to show this. You could just subtract right away. And these are Celsius. So you can see that the temperature in grams units are going to go, and that you'll end up with joule. So when I do the calculation, I end up with, let me think, it's a 1,278.9, but I would round that to 1,280 joules. And then the question wants us to convert it to calories, so we can take our 1280 joules, and then we know that there's 4.18 joules in 1 calorie. So dimensionally, I can do this. So I'm taking really 1280 divided by 4.18, and I get 306 calories. So I hope that helps when you're solving using MCat.